Hello everyone, the purpose of this video is to take you through some of the steps associated with our week 1 activity assignment number 1, which is dealing with rasters. And so part of our activity involves becoming more familiar with raster data in general. That was part of our plan, is to expose you to some different ways to think about raster data and interact with that at not too complicated of a level here yet, but the purpose for us to understand how we can work with vector features, convert them to raster. And you maybe have done that before, but we're just going to step through that again. Learn how we can compute different cell sizes. That was a central portion of our work thus far in the course, is to experience cell sizes, how the difference in cell sizes can impact our results, our accuracy, if you will, of our data, of our output data. We're going to learn about some processing masks and then learn about some general functions for not only calculating area, but also how we can start subsetting different data out of some various raster layers. So first off, let's take a look at some data to be used. And you'll notice in the data provided, or in the assignment directions provided here in our learning management system, you can see that all we really need is our L89 Calc 7-G grid, or our raster. That is located under the training folder that we went through this week, that all of you should be familiar with in terms of going through some of the other content for this week, but that would be located in our grid training folder. If you need help in identifying or finding that folder, please let me know, or otherwise, please take a look up in the rest of the week 1 materials and you'll find that folder. You'll need to download that, unzip it, and you'll be able to find the L89 Calc 7-G data located in that folder under grid intro. Next, you'll need a user-defined mask. And so we'll get a chance to create that on our own. I should also note that you'll notice some of the Word document of what we're seeing here on the screen provided as a link, and also a general solution guide. It's general steps that you can consider. But I'm just going to step you through the audio-visual aspects of that here now. So the objectives are for us to create our own user-defined analysis mask, which we'll do. We'll extract data from our user-defined mask in the form of a 5-meter cell. And then we're going to learn how to work with various cell sizes, to change our first input grid, which will be our 5-meter cell. We're going to talk about how we can change that into a 25 and a 50-meter cell size grid. So we'll end up with 3 different grids, or rasters, that is, grid and raster, one of the same here as we look at that. So our final rasters will be a 5-meter cell size raster, a 25-meter raster cell size, and a 50-meter raster. That will have a 50-meter cell size. So then lastly, we will compute the area in acres for each one of our grids for our value with the largest count. So we're looking for the value with the largest count, and then we're going to compare those cell sizes and the area in between all 3 of those to learn how the cell size changing can impact the results of our data. Now, we're not talking that's going to impact it by hundreds of acres or anything like that, but the question that we spoke about this week is, what is our threshold to dealing with accuracy? And when we have a larger cell size, we're generalizing that a lot more. And when we have a finer cell size, like a 1 meter or a 1 foot cell size, we're going to have our features much more preserved in that manner. But the larger we go, the more generalized or less accurate we will be. So a lot of this depends on our purpose. In terms of the products, a general report formatting is not important for this. I'm not too worried about that in this class, but so long as it follows a general introduction, methods, results, and some type of a conclusion in the introduction, outlining what it is that we're going to do, and then talk about your methodology. Oftentimes when I provide this for people, a methodology is a good way for people to sort of digest everything that they went through and really detail or outline that out as a way to help guide learning a little bit more. Talk about the results, what worked, what maybe didn't work so well, what your general interpretations were, and thinking about that a little bit deeper. and then any concluding remarks that you might have had from a reflective standpoint. So the outputs that you might have is really up to you. Some people used 3 maps side by side, depicting their 5-meter cell raster, or their 25 and their 50 rasters all together, showing the differences between them. Some people use a lot of tables as well as the graphics of the 3 rasters. So it's really up to you, but we want to communicate the story. So that's the goal, communicating the story with our visuals. So with that, let's go ahead and get started. But also note for this lab, it's up to you what you want to use for this. I'm going to use ArcGIS Pro for this entire assignment or activity. So with that, go ahead and fire up your ArcGIS Pro session. And what you can see in my session right here, I simply relabeled my map title. This is really a how-to, how to do the week 1 assignment activity. So with that being said, I deleted my base map in here that you might see. And then also under the catalog, I connected to a folder by right-clicking, connected to my folder. And this is all going to date back to where you downloaded the assignment data. So again, if you need help with that, you want to refer back to that grid training folder, download that data, extract it, ideally to your C drive or somewhere where it's simple path names, again, with no spaces. We do not want any spaces in that directory. So make sure you catch that part, no spaces. And then at that point, that will bring us to where we are here now. So in our catalog, you can right-click, connect to a folder, wherever that directory is. Again, no spaces, and that's where we are. So I connected to my working directory here, which is, in my case, this is the title of it. In your case, you might have a different title, and that's fine. So what I'm going to do is start off in this activity assignment here is to create an analysis mask. And so right away, I do not have a mask, but we're going to work with converting vector features to raster, which is the first item up here. So with that being said, again, I'm in my catalog pane in Pro. I'm simply going to right-click on my working folder here and say New. And then I'm going to come down here to Shapefile. So I'm just going to create a new shapefile in here, or a feature class. For me, it's shapefile is fine. And I'm going to go ahead and select in here the location, and that's fine in here, right where it is, and the name of that. So what I'm going to do is just pause the recording, and then, well, I can keep work through it here. That's okay. We'll call this one my Polygon. That's my Polygon feature geometry type. We're going to want that to be a polygon. So we're not interested in the point or anything. We need to have it to be a polygon, so we convert that to a raster. It'll be a nice area like design. That's what we want, a mask. And okay, the coordinate systems, that's all going to be fine. We're not going to worry too much about that. And I'm going to select, let's make sure all this is okay here. Okay, again, no spaces in our directory. I'm going to create a new shapefile called Polygon. Let's go ahead and run that. Okay, so here we have our polygon. There's no coordinate system obviously here. But now under my map tab here in Pro, I'm going to come over here to add data. And I'm going to add in there the second component to our activity here, which is to add our L89 Calc 7-G raster to our session. So let's go ahead and do that. So I'm going to navigate to the directory where I stored my grid training. Again, that's the folder I was referencing earlier, the data that you will need for this activity. And then into the grid intro. And I'm going to scroll down. I'm going to find my L89 Calc 7-G data set. So I'm going to select OK and simply bring that raster into my session. Okay. Now, being that we had a default base map here, what we'll need to do is to right-click on our raster and zoom to layer. Okay. Your colors might look different from mine, and that's okay, but otherwise your descriptions should all look similar to mine. And getting us to where we need to be here now is just what we want to do. So I'm going to come back out of my geoprocessing here a little bit. and I want to move into editing my polygon. So we're right at the step here where we want to say, I'm going to create an analysis mask, but to do that, I need to first create a polygon. So let's go ahead and do that. I'm going to come up under the Edit tab up here in Pro. Okay, so with that active, I'm going to make sure my polygon is selected here, and I'm going to create a polygon. So all I'm going to do is select this Create a button here, again, under my Edit ribbon, under my Edit tab, and I'm going to highlight my polygon. I always like to highlight to know what I'm up against if I have a lot of different layers in here. But for me, I'm just going to create a polygon. So if you hover your mouse cursor over the different options here for you, get a chance to see what each one does. But for me, I'm going to create a polygon feature. So let's go ahead and do that. Now, this is where it's really fun. You can create this in whatever shape you want. And for me, I'm going to see if I can just make a big old shape, maybe in the form of my first initial here, if I can do that. Again, this could be a square. It could be whatever you want it to be. So kind of a funny one there, a funny looking J, but nevertheless, it gives you an idea of a sample polygon that we created. The attributes really are not all that important for us here at that stage, but I made a sample polygon that will convert now into a raster data set. So with that, I am going to save my edits here. Again, up under Edit, I'm just going to save that. Save all edits. You bet I want to do that. You could also probably use some of our tools down here to do that too. So save, and now I guess at that point, I'm just going to clear any of my selections. And now I'm going to come back over to my map ribbon right here so I can explore my data a little bit. And just for fun, let's go ahead and right click and check out our attribute table of our polygon. You'll notice in here that our polygon should be relatively straightforward. We have a feature ID and an ID, both of those are 0. So when we convert those over to a raster, you also should have a similar looking type of ID. So when we bring that over to a raster, that will essentially mean that our value of our raster will be a 0 because both of these values are 0. We can choose which value we'd want to pull our raster value from. And so either way, it's going to be a 0, but we'll show you what that means. I'm just going to close out of that. Next, let's come back over here to our geoprocessing tab. And I'm going to type in here feature to raster. Feature to raster. And a lot of our activities that we're working through in the course, and in particular in this example, we're just showing you samples or examples of different functions or tools that you can see or look at. So right here, I'm going to select convert a feature to a raster data set. So let's go ahead and select that. Now our input features will be my polygon. Now, here's where I was talking about before. It doesn't really matter which field you bring this over on because both of these fields contained a numeric value of 0. So it really doesn't matter. I'll select my ID though. Now for my output raster data set here, I'm going to, again, make sure this is routing to my work directory, which I'm not working in a geodatabase right now, and that's okay. But instead, I want to route that to my, again, this is my directory. Yours will be something different. I'm going to route this to my DIGA 630 week 1 folder. That's where I want that to be. I'm going to give this a name, and I'm going to call this grid 5. And part of the reason I'm going to call this grid 5, well, we'll call it grid poly, maybe a grid to poly, or no, here, well, let's try it again. We'll call it mask grid. That should work for us. A mask grid. So let's go ahead and call our polygon feature that we're moving into a raster. We'll call it mask grid. Whatever you'd like to, that's fine. Now, right away, we talked about, I want to make this into a 5 meter, a 25, and a 50 meter raster. terms of cell size. So right now I'm going to enforce an output cell size of 5. That way, when I move this over, the raster that my big letter J there will automatically have an output cell size of 5 meters. So let's go ahead and select run. Being that we know we want to move it into a 5-meter cell size anyway, we're kind of jumping into that with the anticipation of that. So it looks like here now, we successfully converted our feature into a mask grid. So I'm just going to come back out of my geoprocessing here, eventually come down to my Raster Calculator. Again, this is located under my toolboxes under Spatial Analyst Tools, which you see here, and then down to Math Algebra. But before we get into that too much, let's go ahead and explore our data. It's one of the rules that we like to always do. It's our #1 rule, explore our data. And no longer will I need this polygon. So I'm going to turn that off and collapse it. And honestly, I could delete it or just move it to the bottom for right now. But let's go ahead and turn off and on our data sets and check these out. And so the mask grid for me, I'm going to right click on that. And let's go ahead and check out first our attribute table. We should have a value in there of 0. And that makes sense for us because we brought over from our Polygon the values of 0 into that. So there we go. So that means pretty much the entire dark area that you see in my screen, everything here, the big letter J, everything is a value of 0 and the count of them. So there are over 230,000 cells that have a value of 0. So that's good. That helps us out. Likewise, let us right click on our mask grid and we'll go to properties. And then to some of our source information. And this is all part of exploring your data, a good practice to get into. Now under our raster information, here we see that we have a cell size of 5, and we see that we have a raster data set or a grid for our format. And our pixel type, well, it's unassigned character, but we know that it's going to be an integer or 0. We know it's a value. And so here we go. Let's say okay. So now we're at the stage in our activity or an assignment here where we've created an analysis mask. So we're all okay to go on that. So part 1 is done. So now let's figure out how we can extract data from underneath the mask in the form of a 5-meter cell size grid. And while we include, so what we're going to do is extract our L89 data that is underneath that grid, or underneath our mask. We're going to extract that L89 data out and make it the shape of our letter J, or in my case, the letter J, but otherwise it would be in the shape of your mask. Okay, so let's do that. A couple ways we can process this that we learned about this week, a few ways. You know, one way is to select or enforce a processing mask. That might be a good way to begin with that. And so a few ways that we can think about that, we'll run through a few demonstrations of that, would be under the Environments tab. We're not worried about output coordinates, so I'm just going to minimize that. And nor are we worried about geodatabase or raster storage here in this case. But let's look under mask right here. So if we use a drop down, we can see that right now I could use my mask grid as a processing mask. So this week we learned about masks. You can go back and review that. But let's enforce our processing mask right here. Now what we can do, if we come back out to our parameters, let's go ahead and create a new raster. I'm going to type that in here. Make sure I'm in the right folder. My directory is all the same. Again, no spaces. I'm going to call this one grid 5. This is going to be the first grid I'm going to create for us here in our activity. So grid 5 is the output. Now I'm going to select in my function window here, in the expression window, is L89. All I'm doing right now is I'm going to say, software, I want you to take L89 and I want you to create a copy of it. And I want you to call it grid 5. Now what's going to happen in that process in our environments, we're enforcing our mask grid. So this big letter J right here. So what that means is going to take out any data that falls underneath that letter J. Let's run it. Okay, so no longer at this point will I need my L89 data. So I'm going to go ahead and just turn that off. Well, I can use it. I guess we'll leave it up there. But my mask grid, I will not need that anymore because I have my new grid 5 here. So that's all ready to go. Move that down. There we go. So now if we turn on and off our layers, your colors are going to be different. Those are just kind of random colors that are assigned to that. But here we see our new grid, our grid 5. We can explore that and check out some of our raster information. Just like we did before, we know that we have a 5-meter cell. So congratulations, we have one of our rasters completed at this stage. So I want to show you another way. So this is step 1. We've already met one of our rasters here. But in class, we talked about another way how we can subset data out to make a grid like this. And let's try that as well. So I'm going to clear this expression in my Raster Calculator. Also, I'm going to go under my environments right now. Again, in Raster Calculator under environments, and I'm going to delete this. Delete the mask out. So we're not processing with a mask any longer. Let's come back over to parameters. And I'm just going to turn off my grid 5 right here and turn on my L89. So I'm just going to show you 2 ways that we can arrive at our first grid, our first raster. So let's go ahead and issue a condition statement. We had an opportunity to highlight that briefly in class. So here's another way to do that. So we're going to use one of our operators over here called, or our tools, our functions here. We're going to use the condition statement. And so this is good practice. It gives you the ability to do this. And I'm actually going to maybe actually come back and use my mask grid for that. We'll use our mask grid again for that. So you can see how this works. So I'm just going to minimize my grid 5 for a moment. So we just created that. We're going to create another mask grid. I'm going to call it grid 5B, or something. So you can see another way to create a subset using the condition statement. So I'm going to add right away another parenthesis to the front because I know we're going to need one for our order of operations. So on the condition where our mask grid, well, try that again. There we go. Where our mask grid is, and we're going to come right up here to the top and use this evaluator. This is a test for equality. So I'm going to double click on my test for equality, and I'm just going to take out an extra space in here. And then what are we going to say here? So when we explored our data before, we know that our mask grid contained a value of 0. As an integer grid or a discrete grid or raster. And we know that it contained all values of 0. So what we want to do is say, okay, software, what we want to do on the condition where our mask grid, in other words, my letter J right here, where those cells are tested and evaluated for values of 0, where that is true, I would like you to write what we want to put in there, our values of L89. So, well, we'll try that again. There we go, L89. And we had this, I had some samples of code out there that we'll share again as we go through week by week, but this was another example from a class, but a condition where site mask equal was tested and evaluated to 1. In our case, it's going to be 0 though. And where it's true, we want to write the values of our L89. So that's how this is looking. So we'll say where mask grid is tested and evaluated for 0, where that's true, we want to write our L89. And where it is not true, we can write either a comma or a 0, or just leave it as well. Either one should be okay. Just going to make our spaces in here. I'm going to delete that space right in the front. We don't want that. Just going to copy this out so you can see what it looks like. This was for assignment number 1 using the con statement. And we'll take out another space in there. This thing can kind of be funny with spaces. Okay, so we want to make sure that we have our parentheses properly placed here as well. So we have a parenthesis here and a here to close this evaluator, and then another one on the very outside to enclose the whole thing. So in the end, we are going to have L89 data or zeros. And I don't think we had any zeros in our L89 data set for values, because otherwise, if we added a value of 0, that could mean open water if we had an open water portion for that. So we may want to just remove 0 and leave it go to no data. So when I say remove it, what does that mean? Well, in a simple way, here we're just going to remove our 0, and the default item will go to no data, which will be null, just won't be anything. So where those values are 0, which is our entire mask, then let's write our L89 data, and where it's not true, it'll be written to null or no data. So let's come back over into our statement, and I'm going to remove the 0, and just going to copy that out and make sure we didn't have any erroneous spaces in here one last time. Oh yeah, we're missing a parenthesis right here. So we'll want to go back and add a parenthesis in there. That's what I was remembering. Okay. Add a parenthesis. There we go. Now we should be good. We're going to call this output grid right here. We're going to call it grid 5. B, it's kind of another trial. I'm just showing you another way, once again, how to create the letter J with a 5-meter cell size. And the same way we used the copy command with the mask. So let's run that. Okay, I'm going to turn off my mask grid, move that down, and let's go ahead and we'll turn off our L89. So here you will see 2 different grids that we just created. Both will be the same thing. Now again, the colors are going to be different, but your values and your counts should all be the same. So those are 2 different ways that we could extract out that data from our initial mask to derive our grid 5, or being our 5 by 5 meter raster. So whichever you'd like to use, that's fine. You can talk about that in your methodology, but for now, I'm just going to delete one of them here for now because I just won't need them. Now at this point, we no longer will really need our L89 and our L89 raster, because we have our original data now, here being our grid 5. So that means we can copy this, we can resample it. There are a lot of different ways that we can just use this raster and derive our grid 25 and our grid 50. Again, our 25 being a 25-meter cell size and a 50-meter cell size. So with that being said, I'm going to clear my expression window. And I'm going to come back over here to environments, make sure that nothing is set that is out of line here. And so let's use a copy. Let's use a copy in our first attempt, and then I'll show you the resample command in our second attempt when we create our grid size of cell size 50. So cell size, let's go ahead and change that to 25. So what we're doing right here is telling the software, I want you software to set anything that's going to be created from here on out to have a cell size of 25 by 25 meters. That's what we're doing here. So I'm going to come back over to my parameters, and I'm going to create a new raster. I'm going to call this one, my output is going to be 25. So that's what I'm interested in, creating a 25-meter cell size raster, just named grid 25 for clarity purposes here. So let's take now grid 5. We don't need any of these other ones anymore because we're just going to create a copy in this case of grid 5. Grid 5, so we're saying software, I want you to copy grid 5, which is what we have right here, and call it grid 25, knowing that in our environments we have an enforced cell size of 25. So that means our output should have a 25-meter cell size. Let's run it. Okay, just to verify, sometimes I like to turn these on and off, and you can see the graininess appear on that a little bit more. But also to confirm, you're probably reading my mind. Let's explore our data, check our properties under our raster information, and there we can see that in fact we have a 25 meter cell size. So very good. So we have our second raster created as part of our process right here. We have 2 done. We only have 1 more to go. So what can we do next? Well, I guess the easiest way, or the most straightforward, you could simply change this to 20 or to 50 rather, and change your output name to a new grid of 50, and just hit run again. But again, we want to make sure we go back to original grid 5. Always copy from your smallest data set. And you could just simply run that from here to generate your grid 50. But I want to show you a different way. And instead, I want to use, just to make sure on this, I'm going to clear out the environments. Okay, our cell size is reset. I'm going to come over here and search in another function called Resample. And this changes the spatial resolution of a raster data set. So it makes no difference. You can use resample command or the resample function for your grid 25 and your grid 50 if you want. You could use a copy, just changing the cell size like I just showed you. It's up to you. It doesn't matter. Nonetheless, our input raster, we're going to use as our smallest grid, or smallest raster, because we always want to start from our smallest resolution. And our output data set, we'll call this one, again, grid 50. That's what we want, or what I want, or whatever you want, that's up to you. So our output name is grid 50. Our input is our small little 5 meter cell size. Now our output cell size, we're going to change this to 50. We want a 50 meter cell size. So this is saying we're going to take our 5 meter cells and we're going to resample them upward. In other words, we're going to make them larger to a 50 meter cell size. Okay, and the sampling technique is fine. There's, I think, a number of different derivatives that we could use. Typically, the default is nearest, and how it relates to the cells for the value. And we talked about that with our encoding methods of how cells are encoded when we move them from different dimensions or sizes in that effect. So let's go ahead and run it. Okay, so that ran successfully for us. I'm going to come out of my geoprocessing window and just come back to my raster calculator just in case here. Now let's take a look at our grid 50. Let's explore our properties. Here you can see that we have our raster information. We know that our cell size did in fact change to 50, and that is great. Again, the colors will all vary. What I like to do on this as well is take a look at them all one at a time. So there's my nice, pretty 5x5 cell size. Now let's turn on our grid 25. See the more granularity appearing, and then our grid 50, which will be even more granular. You can see some of the edges even working against us a little bit there, but working against us in terms of accuracy, that is. So where are we at right now? Well, congratulations, you've created all of your rasters that you need. And so we're up through this stage right now. So lastly, all we'll do is calculate the area in acres for each one of our grids with the value that contains the highest count or the largest count. So for you, that might be different than me. I would expect it to be, but basically go check out your grids, and all of your grids should still have the same value, being the highest. But I'm going to look at my smallest raster here, and it tells me that my value of 4 has the greatest count. So that's the value I'm going to select for all of my rasters to calculate the area of. So if we think back to what our values of 4 referred to, if I go back to my L89 data, values of 4, again, do not confuse this ID with your value. They're different. Sometimes they can be the same, but in this case, they're different. So do not mix this up right here. We want to make sure that we're using the value. So that tells me trees and shrubs were the most predominant feature, the description for my data. So values of 4 have a meaning of trees and shrubs. So that is going to be what I'm going to generate the area. So for my grid 5, I know that my cell size is 5 by 5. So if we took the area, the 5 area, the length and width of a cell size, we talked about this week, we have a total area of 25 meters squared. So what we'll do is multiply 25 meters squared times our count. Here in my case, that's 116,000. And once you have that, well, let's see here. Yeah, I'll try that here. I think I pull my calculator out just to show you how to do. I'll just do one here at 25 for you, or I'm sorry, at 5. And then I can't move this thing because of our window. But nevertheless, we'll take 25 meters squared times 116,873. And that gives me a value. So I'm going to select this and copy it. And now what I would recommend doing is, going into an online converter. I just picked just area online converter. And I'm going to type in here, make sure we know the area in square meters to acres. You use your drop downs to choose those. I'm just going to paste that in there. So this is telling me for my 5 meter cell size raster that I have my total acres here that I'm looking at are about 721.99. It doesn't really matter the number of digits. You may want to go 2 digits past. It's up to you. But 721, almost 722 acres for me in my area here is going to be trees and shrubs for values of 4. So you just have to do it for 4 or for your largest count. For your value, the value with the greatest count. If you want to do all of them, that's up to you. So, but for all of these, like my grid 25, that one as well should contain the largest count. Here we go, right here, 4, and that is the largest count. Again, trees and shrubs, and the same thing with grid 50. That also should have the largest. And if it doesn't, I'd be a little bit concerned, but means maybe something didn't go right for you. But again, value 4, the greatest count here, 1100 plus for me. So for each one of the grids, so for 25 and 50, again, what you'll do is multiply your cell size. So you'll take your area, again, 25 times 25 for the grid 25 for your 25 meter cell size. And for grid 50, you'll be multiplying 50 times 50 to obtain your area, and then multiplying it by your count for that respective raster. So in the end, you'll have 3 different outputs that you can compare and discuss. And with that, you should see some slight, I'll call it a little bit of derivations in your data. There'll be some subtle, lightweight differences. But anyway, that's the whole point of that, is to discuss that in your write-up. What were those differences, and were they a lot? Was it pretty minimal? But it just shows you what can happen when we are working with different cell sizes and how that can impact our accuracy. So I hope that gives you an appreciation for how to complete our week 1 activity dealing with rasters and cell sizes. So have a good week, and please let me know if there's anything I can do to help you out. We'll see everyone again soon.